Hello and welcome to the Mathfolio Grade 7 review series. This is great for test prep and for summer school. This is actually part 4 in the series, and so if you haven't already reviewed the other 3 parts, then that would be a great idea to go back with the worksheet, the packet, and to go through the questions and answers for the first 3 parts. If you don't already have the math packet for this series of videos, then please visit mathfolio.com/7/final review. And so those of you who have made it through the previous 3 parts, congratulations. It definitely shows something about perseverance and commitment to have made it this far. And so without further ado, let's get started. This is question number 31. And so here we are asked when a number is subtracted from negative 5 1/2, the answer is negative 1 2/3. What is the number subtracted? So this is where the word from, which seems all very innocent, crops up and makes things a little difficult for us. So let's take a look. The word from here isn't so innocent. What it does, it kind of switches these numbers around. So let's really think what happens when a number is subtracted. Well, what number? Let's call it n. When n is subtracted from this, so that means we take this, put it first, negative 5 1/2. That's going to be the first number. When n is subtracted from this, the answer is negative 1 2/3. What is the number subtracted? So in this case, we just have to solve this 2-step equation. And so let's go through it. We think to ourselves, what's happening to the n? Well, it's being subtracted from this negative 5 1/2. So let's try and get rid of this negative 5 1/2. To undo it, we would do the inverse operation. So we would add 5 1/2. That would cancel it. And then that would allow us to bring down this n. The problem is that we also have to bring down this minus sign as well. And so over here, we've got to do the same. We've got to add 5 1/2. So now let's think about this. If we're at negative, let's just really think about this. If we're on 0 there, if we're at negative 1 2/3 and we're adding 5 1/2, we know that we're going to go beyond 0. We know we're going to have a positive answer here. So the trick is, well, what number is that? You know, if we've already gone from negative 1 2/3 to 0, well, this is where we need to understand this little move just added 1 2/3. So we're looking at the difference. We're looking at how much more do we need to add. And in reality, this type of a problem can be written by switching them. Instead of negative 1 2/3 plus 5 1/2, we can switch this to say 5 1/2 plus negative 1 2/3. And if we're adding a negative, we're really subtracting. So this becomes 5 1/2 subtract 1 2/3. Now we could take a shortcut and just take this 1 away from the 5 and then continue. But what I'm going to do is just turn everything into an improper fraction first. So 2 times 5 is 10 plus the 1 is 11. This is 11 over 2 minus, so that's 3, that's 5 over 3. Now when I try and get common denominators here, the common denominator could be 6. 2 into 6 is 3, so 3 times 11 is 33. 3 times 2 got us to the 6, so we do the same to the 5. 5 times 2 is 10. So this gives us an answer here of 23 over 6. Now 6 into 23 goes 3 times, it's almost 4, but not quite. It goes 3 times, which makes it 18, and the remainder is 5, so the 5 goes back over the 6. So now I'm going to take this little piece and put it over here. So this becomes 3 5/6, but this is the value of negative n. We're asked what is the number subtracted, and over here we gave the number subtracted a name. We called it n. We basically defined a variable, let n equal the number subtracted. But at the moment we have negative n here. So to undo it, we need to think, well, if we have negative n, this is really the same as saying negative 1n. So to undo this, we would divide by that coefficient, which is -1. Divide by -1. The negative ones would cancel out, and we'd be left with n equals, and anything divided by 1 is itself, but this time it's divided by a -1, so the negative stays. So our answer is n equals -3 5/6. That's our answer to question number 31. Okay, 32. So in 32 we're told Kate played chess with her sister 10 times. The results for wins and losses are below. So I'm just going to do a very quick table. The wins, we've got 3, 4, 5, 6. We've got 6 wins there. The losses, 1, 2, 3, 4. So quite rightly, this is 10 times, 10 games. We've got 6 wins and 4 losses. So now we're told, using the information above, what is the probability Kate will beat her sister in the next game? So probability Kate wins the next. Now, there is no theoretical probability as such. It's not like we're flipping a coin and it's 50-50 chance of being heads or tails. It's not like we're rolling a die and it's 1/6 chance of any of those numbers coming up. For things like this, we can only base our probability on what we observed and what really happened. And this is called experimental probability. And over here we see that 6 out of 10 was a win. So we observed 6 out of 10 times as the probability that she would win based on what did happen in the past. So this is the fraction. It also wants us to leave our answer as a decimal and a percent. So before we do the decimal and percent, this fraction can be simplified to 3/5. The decimal we can derive by looking at this fraction. The 6/10 tells us the 6 is in the tenths place. So this is a shortcut. Just write the 6 in the tenths place, and that's 6/10. That's our decimal. And then to go to our percent, we would take the decimal and times by 100. So we would move this point over 2, and that would give us 60%. So our answers are 3/5, 0.6, and 60%. And that's our answers to those are our answers to number 32. Okay, question number 33. In this one, usually when they throw up a rectangle, we're dealing with area or perimeter. In this case, we are asked to find the perimeter of the shape below. Even though it doesn't show right angles, we can assume that this is a rectangle. And so we have a couple of formulas. We have P equals the length plus the width plus the length plus the width. That's one way to remember the perimeter, just as though we're walking around the entire shape. How far would we walk? The other way to remember it is P equals 2 times the length, because we're just combining these two L's, plus 2 times the width, because we are combining these two widths. So this second formula is probably the one we're going to use to make our lives a little easier. So in this case, let's just say that this one on the bottom is the length, and let's just say that this one over here is the width. So what we're going to do is take perimeter equals 2 times the length, so 2 times 3y minus 7/8, and then we're going to add 2 times the width, which is 2/5 y plus 2. So now, in order to answer this, we have to simplify it a little better. To be honest, how it's written is a correct answer. It's just not simplified. So we've got to do 2 times by 3y, which gives us 6y. We then do the 2 times by the 7/8, which gives us 14/8. And if we need to, we can just remember this whole number 2 is really 2/1, and then do 2/1 times by 7/8, gives us 14/8. Because this is positive and this is a minus there, the minus is going to stay. And then we're going to add the 2 times the 2/5 y, which again, if we need the 2/1, we can just write it in there. This gives us 4/5 y plus, now we've got to do the 2 times the 2, which is 4. So the next step involves us combining like terms. And so what we have is we have 6y's plus 4/5 y's. So that's 6 and 4/5 y. So we used it, so I'm going to cross them out. The next step, I'm going to change colors for this. It's going to get a little messy, but we have a 4 here, and we have a minus 14 over 8 here. So I'm going to switch the order. We can do that with addition. The commutative property works for addition, so we're allowed to switch. It doesn't change our answer. So this becomes 4 plus negative 14 over 8. Now, this 14 over 8, we could change this into a mixed number. 8 goes into 14 once, remainder 6. That's 6 over 8. The next thing to do here is to think, well, when we're adding a negative, we're subtracting. So this becomes 4 minus 1 and 6/8. But before I write the 6/8, we can simplify this. Divide by 2, divide by 2. So it's minus, instead of 6 over 8, it's 3 over 4. And remember, we're just trying to figure out these two orange triangles to find out what happens when we combine these numbers. So now 4 minus 1 would give us 3. So this is the same as 3 minus 3/4. And so in this case, we're going to have 2 and 1/4, 2 and 1/4. So let's just double check this. This is going to be 6 and 4/5 y from the y's. And then we are going to add 2 and 1/4. And so this is our answer for the perimeter. And we don't have any units up there, but we could write this as a sentence. We could say the perimeter of the shape is, and then 6 and 4/5 y plus 2 and 1/4. And we could just leave our answer as this. Question number 34. We're told that 3 sides of a triangle are 15, 15, and 6 centimeters. So we know that the longer sides are going to be joined by something that's shorter, because this is 6 centimeters, this is 15 centimeters, and this is 15 centimeters. So although it isn't to scale, it would kind of look like this. And we know that this is an isosceles triangle, and these two sides are the same, and these two angles are going to be the same. So what information can we conclude, if any, from the following statements? So it must be a scalene triangle. That's not correct, because we know two sides are the same and the two angles are the same, so it can't be scalene. It must be an obtuse triangle. Well, there are some cases where an isosceles triangle could be obtuse. So let's remember that an obtuse is where the angle, let's just say it's theta, the Greek letter theta, is greater than 90 degrees. This is when we have an obtuse triangle. So let's take a look at this. Let's take our same 15s, let's put them this way, 15 centimeters and 15 centimeters. Now in this case, the angle, say theta, is in the middle of isosceles triangle in between the 15s, but this cannot equal 6 centimeters here, because it would have to be larger than the two 15 centimeter angles. So in this case, this could not be true. And so because this side here, the 6 centimeters, is smaller than both the 15s, it means that this angle at the top, theta, must be acute. So theta must be less than 90 degrees. That's for sure. Okay, so it cannot be the second one. Okay, it must be an acute triangle. Well, I'm thinking this one must be the case, because all angles are less than 90 degrees in this case. Okay, let's just double check though. The last one, it must be a right triangle. Well, the only way for this to be a right triangle is if these two sides that are 15 centimeters and 15 centimeters, if this is a right triangle, then they must both be adjacent to each other, which means that the hypotenuse must be the other one, the 6 centimeters. And this cannot equal 6 centimeters because it's the hypotenuse. It's opposite the right angle, and that side must be the longer side. And obviously 6 is not greater than 15, so it cannot be the fourth option either. So in fact, with this information, we can conclude that it must be an acute triangle. 35. Okay, so in this question we are told that a local sporting goods store introduced a rewards program, okay, where customers receive 10 points. So I'm just going to write this here, 10 points for every $100 spent. This is for every $100 spent. So then it says write an equation for the total points P a customer receives when they spend X dollars. Wow. Okay, so let's think about this. If somebody spends X dollars, so X is the spend, and P is total points. So we're told these letters, we can't change them or anything. We're given these letters, we're stuck with them. But it wants us to write an equation for the total points P a customer receives when they spend X dollars. So P, which is the points, equals, now let's think, X is what they spend. Now, if they spend 100, they get 10. They get 10 points if they spend 100. So let's just think about this. So we need the value that they spend divided by 100, which would tell us how many hundreds are in there, how many $100 are in this amount that they spend, and then however many $100 are in there, we're going to times each of those amounts by 10 because they get 10 points for each $100 that they spend. So in this case, we've got P equals X times, well, if we're timesing this, we've got to put the invisible 1, or at least know it's there. X times 10 would be 10x. 100 times 1 is 100. And now what we can do is we can start to simplify. We can cancel out 0, so 1x divided by 10 is the same as x over 10. So when I clean this up, I end up with the equation that they're looking for, which is P equals x over 10. And so just to check this as a check, I'm going to do something over here, check. Let's just say that they spend, let's just pretend that x is $500. So if someone spends $500, according to the formula, P equals x over 10, this would equal 500 over 10, and that would give me 50 points. Now let's see if this makes sense logically. So we're told that they receive 10 points for every $100 spent. So this person spends 100, 100, 100, 100, and 100. That's 5 hundreds there. They spend $500 and they get 10 points for each of these hundreds. And so this does give us 50 points. So it does work, 50 points. So this equation here works for everything. So even if they came in and they spent $4,200, we could then just plug that number into the x. And this is again is just an example. We would plug that into the x and we would work out 4,200 divided by 10 is 420. So they would get 420 points. So the example does work. Okay, question 36. Okay, so in this question we're told, what is the surface area of a rectangular prism? So we could draw this, and if you want to draw it, the ways to draw it is to draw a rectangle, draw exactly the same rectangle further away, and then connect the lines to each other. So just go top right to top right, bottom left to bottom left, and then we can't go wrong. So if we're told that the height is 5 inches, the length is 12 inches, and the width is 2 inches. Okay, or we could just write it like height equals 5 inches, length equals 12 inches, and the width equals 2 inches. Now it wants to know the surface area. So usually you'll be given a formula sheet, and this formula would be on there. The formula for surface area of a rectangular prism is 2LW plus 2LH plus 2WH. Notice that the LW and the LH and the WH, they don't appear more than once. We don't just switch these around. What it is a different combination. Here we got an L and a W. You will never see an L and a W again, or a W and an L. So now we can just plug in. So this equals 2 times by length times by width plus 2 times by length times by height plus 2 times by width times by height. So if we continue this, 2 times the 2 is 4, 4 times 12 is 48. So it's 48 plus 2 times 12 is 24. 24 times 5 is going to be 120. Let me just check that. 2 times 5 would give you 10, and then 10 times 12 would give you 120. So we can switch the order when we multiply. In this case, 2 times 2 is 4, 4 times 5 is 20. So our answer is going to be 120 plus 48, so that's 168, plus another 20 is 188. And so we need units with it, and also we should write it as a sentence, so we can say the surface area is 188. Let's look back at the units. Everything says inches, which is great, so we can say inches, but now inches is just from, it's like a piece of string, it's a length, it's a distance. Here we're looking for area, so we must say squared. So the answer is the surface area is 188 inches squared. Okay, so question number 37. Solve and graph the following inequality on a number line. Okay, so we've got 2/3 x plus 15 is greater than 16. Well, okay, so I'm tempted just to distribute this whole thing, which I definitely could do here and then start to solve it. I could do the 2/3 times by the x and the 2/3 times by the 15. But really, because this is 2/3 times everything in this parentheses, I can get rid of the 2/3 and turn it into a 1, which basically evaporates this whole thing by just dividing by the 2/3. And because it's a fraction, instead of dividing by 2/3, I can multiply by the reciprocal. And just as we saw previously, 2/3 times by the reciprocal 3/2, remember this is 2/3 times by 3/2, equals 6/6, which equals 1, and 1 times this is just itself. So these would cancel, and we would bring down x plus 15, and greater than. But remember, we've got to do this to both sides. If we're timesing by 3/2 over there, we've also got to do the 16 times by the 3/2 here. And so the 16 can be written as 16/1. 3 16s are going to be 48. 1 times 2 is 2. So this equals 24. 48 divided by 2 is half of 48. That gives us 24. So I'm just going to put my 24 in there. Now notice that this isn't an equation. This is an inequality, but we can still put the dotted line as though we were solving a two-step equation. So now this actually isn't too bad. I'm going to switch to red because this is now a one-step inequality. We're just going to take away the 15, and this is going to reveal the x on its own. The x drops down, and x is greater than 9. So we just solved it. X is greater than 9. But now we need to graph. So graphing it is the next step. So I'm going to take an orange color. This is our number line. Let's label 0 in the middle. Let's also label 9. And we're told that x is greater than 9. So with my blue pen, greater than 9 is over here. So I'm showing it by shading in with an arrow, and that shows us all the numbers greater than 9. But we can't leave it like this. We have to think, can x be 9? Can x be equal to 9? And it can't. It must be greater than. So in that case, we have to do an empty circle on 9. And this is our graph of the inequality, x is greater than 9. Okay, question number 38. Okay, so a Pringles can is cylindrical, and it has dimensions of height approximately 10 inches and radius approximately 1.5 inches. So cylindrical means it's a cylinder. So we could draw it, we don't necessarily need to. And again, when you're drawing shapes like this, you could just draw a circle on the bottom, draw the same circle on the top, and then connect them. And that's one way to show this. Okay, we're told that the height, h equals, well really it's approximately, so let's do wavy equals lines, equals 10 inches, and the radius is approximately equal to 1.5 inches. So the first thing it wants us to do is calculate the surface area. So A is the surface area. Now for a cylinder, and this will probably be provided on most formula sheets, but if you can remember it, that's going to save you some time. The surface area is the area of the two circles, top and bottom. So that's 2 times pi r squared, because pi r squared is your area of one circle. You've got two of them. And then you're going to add 2 pi r h. So this is going to give you the surface area. So let's continue to calculate this, and I notice it says leave both answers in terms of pi, which is going to help us. We don't need a calculator. We don't need to do times by 3.14 or times the pi button. We can just plug in. So this equals 2 times pi times r, which is 1.5 squared, plus 2 times pi times 1.5 times 10. So this is 2 pi r h. So in this case, we're going to need to do 1.5 squared. So 1.5 times 1.5. 5 5's 25. 5 1's 5 plus 2 is 7. Then 1 times 5 is 5. 1 times 1 is 1. So this gives me answer of 225. Now, we're almost there. Because this is a decimal, 225 is really 15 times 15. So what we've got to do is count how many places over the decimal point is. There it's 1 over, and there it's 1 over. So when we add these, we get 2. So in our final answer, we must put this point in 2 places over. So our answer for our answer for the radius squared, 1.5 squared, is 2.25. Okay, so let's come back up here and continue. This equals 2 pi times 2.25 plus, well, 2 times 1.5 is 3, and then the 2 times 1.5 is 3, and then 3 times 10 is 30, so this is 30 pi. So 2 times the 2.25 is going to be 4.5 pi plus the 30 pi. So this is going to give an answer of 34.5 pi, and our units for this, because we're given inches in the question and this is surface area, our units are going to be inches squared. So this is our answer for the surface area. Now for B, I'm going to change color to orange. For B, the volume formula is pi r squared h. Now pi is going to stay in our answer. R squared, we worked out r squared to be 2.25. So this 2.25 can go here, 2.25, and our height is the 10. So when we're timesing by 10, that point's going to jump. So this becomes pi times by 22.5. Now we always write the number first, so this is going to become 22.5 pi, and for volume, we're going to stick with inches, which we were given, but it's inches cubed, and so this is our volume. And up here, this is our surface area. Okay, so again, these formulas will probably be provided, but if you can remember them, I'm just going to draw arrows to them both right now. This is the surface area of a cylinder, and this is the volume of a cylinder. Then this can really save us some time and some problems in future. So question number 39. Okay, so Barry is saving for an engagement ring for his girlfriend. It costs, so let me start writing down this information. It costs $1,250. That's this first piece of information. He already has $480 saved. And he can save $120 per week. Can save from his wages. So he's not spending all of his wages on this. He's still paying his rent and doing all that other stuff. But he can save $120 per week. So the question starts here. How many weeks must he continue to save until he can afford to buy the engagement ring? And then we're told, write an equation to represent this situation and solve it. Okay. So we're after how many weeks? So inside our important information over here, I'm going to say let W equal the number of weeks. Okay, now we're going to get on to the fun stuff. So the grand total of what he needs is this 1,250. So I'm going to put that over here. 1,250. Now what he has already is the 480. And sure, this amount's going to grow. It's going to be added with 120 every week. So if this was just 3 weeks, we would add 120 times 3. If it's 10 weeks, we would add 120 times 10. If it was 1 week, we would add 120 times 1. However many number of weeks there are, we would multiply by the 120. And we've said let W equal that number of weeks. So whatever the W is, whatever the number of weeks are, we're going to multiply it by 120. And so to do that, we just put the W there. And this is our equation that represents this situation. 480 plus 120W equals 1250. So we're not done yet. We need to solve it, and then we need to answer the question. So I'm going to put my dotted line. I'm going to subtract the 480, because let's remember, we think what's happening to the W? It's being multiplied by 120 and then added with 480. And so to find the W, we need to do inverse operations in order. So if the last thing that's happening to the W, let's listen again, the W is being multiplied by 120 and then added with 480. So to undo it, we do the last thing, the add with 480, and we undo it. So the inverse operation is the inverse operation of to add to 480 is to subtract that 480. So we're going to do the same over here as well. So these cancel. The 120W comes down, and this equals, well, 0 minus 0 is 0. Here we've got to borrow. 15 minus 8 is the 7. Here we've got to borrow. 11 minus 4 is 7. So 120W equals 770. So now what's happening to the W? It's being multiplied by 120. So the inverse operation is to divide by 120. We've got to do the same to both sides. Here the 120s cancel and we're left with W equals. Now we could try and do some work on this to simplify it a little. So 770 divided by 120. For a start, we can cancel the zeros, and so really this fraction, this division or fraction, is really 77 over 12, which is 77 divided by 12. So we could write it like this. Remember, the first number you say goes in the house. 6 times 12 would give you 72. If we take this away, we would be left with a 5 there. So the remainder is 5. Now, what we can do in this case is, instead of continuing this decimal on and dropping down zeros, etc., we can take that remainder, the 5, and put it back over the 12. So we just put it back over the 12 here. So our answer is 6 and 5/12 weeks. Now, because Barry is probably not going to get paid his wages in the middle of the week, we really, just from logic and being reasonable, we have to know that he's going to get paid at least at the end of that week, if not at the end of the month. So we can't round this thing down, but we also can't just leave it as 5/12 of a week in there as well. So we have to round up. We have to say that this is our solution so far. But when we answer the question, how many weeks must he continue to save, we've got to say he must continue to save for 7 weeks. We have to round this thing up until he does get that paycheck that includes the 5/12 of a week as well. So he must continue to save for 7 weeks to be able to afford the engagement ring. And so that was that was question 39. Question 40 really isn't a question that we have to do any work on paper. This is really just about reflection from these 4 parts from this series of 7th grade final review test prep videos. So if you've completed all 4 parts, then really that's a huge task. You should definitely be proud. I am. And when you look back, one of the things that you've got to ask yourself is, truthfully, how did you do? If this was more of a copying exercise from my answers, then that's great the first time around, but we need to get you to a point where you can do this on your own. Was it difficult? Were some questions easier than others? But could you answer all these questions again without the use of this video? That's a true sign of understanding. If now you could go back and you could answer these, and maybe you could use a different method, but could you get the same answers as we've got in this video? Okay, so thank you for watching the 4 parts. Appreciate any feedback in the comments, and please also subscribe to the channel and you'll receive some updates when some new stuff is posted. Many thanks again.